I want to look at Neuron Model 1. Neuron Model 1 is a model in which the cell body or soma is separated from the axon and mounted on a green board. Here is a model of the cell soma on the right. This is also called the cell body. On the left is an extension of the axon. We're going to start by focusing here on the cell body or soma. Inside the cell soma, there's the nucleus. And these peach or pink, pick your color, rubber extensions here are the actual axonal endings of a previous neuron interfacing with the white dendrites. And we can even see here the neuronal junction or synapse between the axonal ending of a presynaptic neuron interacting with a dendrite area of the postsynaptic neuron. Here I have blown up the axonal ending, and this is where the action potential would transport down from the original neuron. And in here, these little white vesicles are synaptic vesicles full of acetylcholine. And the acetylcholine will then come out of this axonal ending, diffuse across the synaptic cleft, bind to a receptor, which is linked to a sodium gate, open that sodium gate up, and allow sodium ions to flood in and start depolarizing the next neuron in the chain. The next portion of the model I want to look at is the axon, which is myelinated here. This little white stump is an extension of the axon coming off of the soma or cell body. And here we have a longitudinal section. Now I have a lot of students that get confused by this, so I'm going to do my best to explain it. This white wrapping is made by this Schwann cell, or the nucleus of the Schwann cell, and it literally wrapped the axon in a circular motion. This myelin sheath was made here, and you can see this little raised bump, which is what's left over from that Schwann cell. This red stripe down the middle is a longitudinal section of this axon. So we've taken the axon, which is myelinated, and cut it in half and exposed the half so that you can see it. We can see a few things inside of this axon. We see these little red structures with squiggly lines in them. Those are going to be mitochondria, which take care of providing energy for this neuron. And the white, like I said, is the myelin sheath. The little joints here are called nodes of Ranvier or nodes of Ranvier. I've heard it pronounced both ways. And what literally happens when the acetylcholine is released from the presynaptic neuron, diffuses across the synaptic cleft, binds to a sodium gate, and allows sodium to flow into the axon. The sodium changes or depolarizes the axon, and like a series of dominoes, it flips, going from positive on the outside to positive on the inside. It transports all the way down the axon. But the beauty of the myelin sheath is it speeds it up. The axon doesn't have to actually depolarize all the way. It hops from node of Ranvier to node of Ranvier. So it speeds up. It's like taking 2 big steps or 30 small steps. So it's a lot quicker. And this is a good way to speed up nerve impulses. To wrap up this model, I've got a picture here of a cross-section of the axon, and we're going to go from the inside out. Now inside this red, this is the axon, and our previous picture showed a longitudinal section. So we saw all of the myelinated axon from about where I'm drawing an imaginary line here down. So we see the axon, it is wrapped in a spiraling pattern of myelin laid down by this Schwann cell. There's the nucleus left of the Schwann cell. And on the very outside is this connective tissue called the endoneurium.